All right, chickens. We are checking out Chapter 6.6, Systems of Inequalities. Man, one inequality just wasn't unequal enough. Sweet. Great. So, we've already looked at how to find solutions to one linear inequality. Now we want to look at a whole system. So, just like a system of equations, this coordinate, if it is a solution, and all we're trying to do here is identify it, if it is a solution, it will make both equations, and in this case inequalities, true. So let's try it out. I know we've got an x, we got a y, and so we're going to plug in our y into the top equation, plug in our x into the top equation, simplify. So we've got negative 3 times 0 is 0, plus 2. 2 is 1 less than 2. Yeah, this works. This is true. So this is a solution for this inequality. So let's try our second inequality. Plug in x, plug in y. Here's our y value. Here's our x value. Here's our y value. Here's our x value. 0 minus 1 is just negative 1. Is 1 greater than or equal to negative 1? Yeah, this is true. So this is a solution for this inequality as well. Great. So since it's a solution to both inequalities, it's a solution to the system. Sweet. All right. So let's check out this one. We want to see if 0, 0 is a solution to this system, meaning it would have to be a solution to both inequalities. So here's my x, here's my y. Plug in your y into the top equation. Plug into your x. So x times negative 0 is 0, and 0 plus 1 is 1. Is this true? Yeah. So this is a solution to this inequality. But let's check out the second one. If you plug in 0, 0 here, you get 0 for your y, greater than, plug in 0 into your x, it would be 0 minus 1. Is 0 greater than negative 1? No, not true. So this is not a solution for this inequality. So therefore, not a solution for the system. Cool? So 0, 0 is not a solution for the system because it only makes one of the inequalities true, not both. Sweet, moving on. You guys know how to graph systems, inequalities anyway. So graphing systems of inequalities is no different. You just graph two of them. So graph both of the inequalities, yeah? And shade, but be careful where you shade, right? The regions where the shaded areas overlap will satisfy both inequalities. So that any point in the double shaded region, those are the solutions to the system, okay? So here's an example. I want an ordered pair that is a solution to the system. Now there might be infinite, there might be none, right? But first graph them. So if we're going to graph this is y greater than 1/2 x minus 2. Well, here's the line for that. Here's our y-intercept, negative 2. We rise 1, we run 2. It's a dashed line because this is greater than and not greater than or equal to. So the points on the line are not part of the solution. And then shade them in, right? So you should know how to shade by now. Bing. But you can take a point like 0, 0 and plug it in here and see if it's true. So 0 is greater than or equal to. If you put in a 0 in here, you end up with 0 is greater than 0 times 1/2 is 0, minus 2 is negative 2. Is this true? Yeah. So that was this point. So everything on this side of the line, we're going to shade. All that. Great. Do the same thing with this. Now you can do this with the covering method, right? You plug in 0 for your x, and so you get let's see, 4 for your y, and 4 for your x, 4 for your x, and 3 for your y, and you end up with this line. Great. And when we shade it in using this same principle, we end up with this shaded region. Great. And so this is how we look at the system. But what are the solutions to the system? Everything in the double shaded region. So everything in here in purple. Okay? So let's get a for instance. Okay? Well, 0, 0 would be one that works for both because it's in the double purple region, right? We saw that it works for this one. Let's see if 0, 0 would work for this. It would be 0 times 3, which is 0, plus 0 times 4, which is 0. Is 0 less than or equal to 12? Yeah, bing, so it's a solution for both of these, so therefore 0, 0 is one solution for both, for the system. Okay, let's pick something else. Let's pick, how about even this point? 1, 1, right? That's inside this double shaded region. Plug it in here. You'd get 1 is greater than 1/2 x, so it would be 1/2 minus 2. So this would be, see, negative 1.5. Is that true? Yeah, right? So it's a solution for this. Plug in 1 into here. 3 times 1 is 3. 4 times 1 is 4, and so 3 plus 4 is 7, right? Is 7 less than or equal to 12? Yeah, bing, so the point 1, 1 is also a solution to the system because it satisfies the top and the bottom inequalities. Sweet. Moving on. So let's try it again. You can pause me now and try it yourself, or you can keep on watching. So here's a system of inequalities that we're going to try to graph and then find a solution for. All right. So we're going to graph this. Let's graph the top one. Right. That's our green or blue inequality. And so we start at -7 and we rise 1, run 1, rise 1, run 1. That's our slope is 1. Okay. And when we shade it in, there's our shaded region. We can graph this the same way. I would probably do it with intercepts. So we find our 2 intercepts, and then when we shade that in, you get that region. All the double shaded regions, everything in here, all the solutions in here are solutions to the system of inequalities, right? And so let's try 0, 0, because that's in the double shaded region. So I want to know if 0, 0 kind of looks like a smiley face. Yay, cool hair. Nope. 0, 0. Well, I want to know if 0, 0 is a solution for this system. So plug it in here. Is 0 greater than, well, 0 minus 7 is -7. Is that true? Yeah, bing, that's true. Bing. So what about this? 0 times 3 plus 0 times 6 is 0. Is 0 less than or equal to 12? Yeah, true, too. Bing, bing, great. Okay, so this is a solution to this system. Hooray, as are all of these other points. All of these points in the double shaded region are solutions. Kind of looks like a rainbow shark. Hey, cool. All right, moving on. So, sometimes you'll get parallel boundary lines, right? Here's 2 inequalities, and they give you parallel lines, and they shade on opposite sides. So sometimes you get like this shaded region and this shaded region. There's no overlap, right? Here there's overlap, there's purple region, but here there's no overlap. So the system has no solutions when this happens. How do you know? Well, you can graph it, right? Or you can just plug in numbers and you'll never find a solution, okay? This is when you get parallel lines, and from this line, everything is shaded that way, yeah? And from our red line, everything is shaded this way, and your solutions are the overlap. Cool? So the solutions are only the ones in here. Yeah, you get overlap. Okay? And then there's yet another system type where if you have 2 parallel lines, one is shaded a certain way and the other one is shaded in the same direction. Your only solutions are where they overlap. So the one that's just blue is not part of your solution set, but all of this is. Cool? So in here, the solutions are the same as just this line, right? This system. Cool.